Well, I want to welcome everybody who's watching to another monthly online program for Central Mississippi Amateur Radio Association. Thanks to JDK5HH for not only his access to his Zoom account, but for handling the Zoom episode here for us. And he's got the record button on, so I'm sure he'll have it online soon enough. It's a real privilege for me tonight as the person who's the program chair this year to introduce our speaker. Tom Brown, AE5I, is no stranger to the club. A few years ago, he gave a back-to-back monthly presentation on oscilloscopes. And when I approached Tom, I said, Tom, you know, it's just a terrible thing that we didn't get the first one recorded. I think we got the second one recorded. But I want you to come back if you've got time and talk about test equipment. But I want you to focus kind of narrowly on how to get started and the things that you think every ham who may not call it a workbench, but they've got some place that they work on something. So Tom agreed to do that, and he has been hard at work, and I'll let him tell you what he's going to talk about. But he did tell me that he's going to talk about 3 pieces of equipment, and you can spend very little or a lot, your choice, on acquiring some of that equipment. And Tom is gonna talk to us about that. And I can think of really no one else here in the Jackson area who is anywhere near as knowledgeable as Tom Brown is about test equipment. He is my Elmer and my guru and my go-to guy on anything involving that, as well as some other things. So it's a great pleasure. I want to introduce Tom Brown, AE5I, former RF engineer for WJDX, and he was followed by none other than George Thomas, W5JDX, our first speaker this year. But Tom, I don't think you ever set your rig on fire like George Thomas did. So try not to set one of these pieces of equipment on fire. But I don't know if you know the story of that, but George Thomas had a sensor, and it said his rig was on fire. So I hope you don't follow that. But anyway, this is Tom Brown. Tom, over to you.
Well, thank you, Frank. You're a kind soul indeed, and I have to say you're quite good at making an old guy feel useful, and I appreciate that. And I'll tack something on to your story about George's rig catching on fire. We also had a common history at WZZQ with an old Visual brand FM transmitter that it caught on fire. It arced holes in the cabinet. It burned up contactors, breakers. And I was down there one night when it struck an RF arc, which ran for several seconds, and then it discharged 7 kV at 5 amps into the side of the cabinet and knocked a hole in it. So
now, a little trivia on WZZQ. Who is the other famous ham who was an engineer at ZZQ?
Wait a minute.
Guy named Gerald Youngblood.
Gerald Youngblood, yeah, he was there
Flex
before
Radio
me.
Systems, correct?
He was there before me in I want to say mid-70s maybe.
Yeah.
And I think I came along right after him, but he had been gone for a little while.
Yeah.
But anyway, so we're all alumni from WJDX ZZQ. Anyway, this is a useful thing. The idea of having the right test gear in a ham shack. I honestly can't think of a place that has a greater need and can see more convenience and prevention of problems and correction of problems with the right test equipment. As Frank said, tonight I want to talk about basically three pieces. Oscilloscope is one, network analyzer, and I've got one of the little nano VNAs here that we'll look at. I know everybody's seen those, and I'm going to tell you something, at the price they are, there's no reason everybody who wants one couldn't have one. And then meters. We're going to look at analog and digital multimeters. Frank and I discussed this at length, and we figured that these were basically the three legs for the stool as far as test gear in a ham shack. this is just a signal generator that I brought to help with the demo. And I'm old, so I'm going to refer to my notes. Figured better to concentrate on 3 pieces than to shoot wider and talk just a little bit about many more, although there are many more that are relevant, RF watt meters and all that sort of stuff. But the first one that most people will grab when they have a problem is a multimeter. And I think, whereas many hams have a meter something similar to this, this is a WaveTech DMM. It is the poster child for versatility. I bought this one several years ago because another meter I had that measured capacitance and inductance and things had developed problems. Turn her on. As you can see, it's pretty standard. Single rotary dial, a few menu and on-off minimum and max buttons. This one also measures a wide range of capacitance. It has a special diode check function, wide resistance range. It has special positions for watching TTL logic and CMOS and all that sort of stuff. It measures frequency from 20 cycles to 2 megacycles. No, 20 megacycles, all right. AC and DC voltage, AC and DC current. Lot of function. It was not an expensive meter, runs off of a 9-volt battery. And refer to my notes, the digitals have specific strengths and weaknesses. The most obvious strength of a digital is accuracy. I don't have the specs on the tip of my tongue for this one, but it would not surprise me if it was better than 0.1 or 0.05%. That's fairly typical, particularly in bench meters. Easy to operate. Basically, you set the range. If you're trying to find out what resistance you have through a circuit, you can put it on the ohm scale, hook up the leads, rotate the dial until you get a reading, and it will directly read to you digitally what your value is. Couldn't be much easier. Got a couple of other notes on that. Oh, and a lot of digital meters have true RMS capability. That's handy. Sometimes, particularly in work that I've done, overhauling and maintaining old oscilloscopes, there are 1 or 2 that have saturable inductor regulated heater supplies for the CRTs. And in order to properly set that regulator, you have to be able to read the true RMS value because the saturable inductor distorts the waveform. So I've always kept at least 1 or 2 of these to be able to do that. There were analog meters that would do that, but gosh, they died out a long time ago. I've not seen one of those in a long time. The digitals also have some weaknesses, and I'll demonstrate the most common one right now. I'm going to set this one up. I'm going to start on the 20-volt scale. I've got some output coming out of my signal generator here. Let's see. Okay. Just going to clip on. Okay. Now, Becky, can you zoom in to where you can see this? Mm-hmm. You guys can read the digits. Basically, what you're seeing there is the meter telling us I have no idea what I'm looking at. It's the readings are gyrating randomly all over the place, and literally, if you hooked up to that circuit, you would not be able to get any sort of useful display on a DMM. So what we're going to do, this will illustrate one of the big differences between digital and analog. I'm going to swap out, and I'm going to hook up to a classic. Hey, can you get into where you can see the meter face?
Yes.
I'm going to hook up. Let's see. Actually, I'm going to choose AC, I believe. Yeah. AC volts. There we go. going to switch down to the 2.5 volt range. Now, if you look at the analog meter, you can easily see what's happening. The voltage is repeatedly going up and down. And you're not going to get, depending on how fast it is, you're not going to get an accurate reading, but having the analog meter hooked to the circuit tells you sort of what's going on in the circuit. And that dovetails into advantages of an analog meter. One of them is the ability to tell what on earth's going on with a semi-complex signal. The display response is faster. The display is non-ambiguous in a situation like this. And just to answer the question completely, let's jump over to the oscilloscope and we'll see what's really happening in the circuit. This is what makes the scope so valuable. I'm going to hook it up. Now, can you get into where you can see that, boss? Mm-hmm. I've got this sweeping very slowly, 200 milliseconds per division, and let me turn up the scale. Oh, need to replace the scale bulbs in that one. Anyway, what's happening is that's actually an AC signal that's going above and below zero, and it's repeating on a very slow period. So in that case, the DMM told you nothing. The analog meter told you a little bit. The oscilloscope tells you exactly what's going on. And that's kind of meant to, as Frank said, the meter is the first thing you grab, but it kind of shows you where you may go. Now, before we get off of meters, let's see. One of the disadvantages to the analog meter is accuracy. This Simpson, I want to say, this is a Simpson 260 series 8P. The P means it's protected. There's a circuit breaker right there. This meter probably is 2%, 1.5%, 2.5%. There's a model 270 that's 1%, I believe. That's the main disadvantage to an analog meter. This is why I say that a ham shack really needs to have both. They don't need to be expensive. I have seen Simpsons for $30 to $50 on eBay. I've seen them for that or less at Hamfest. They made a ton of them. They actually still make them. And, but I think they're probably $150, $200 nowadays. But anyway, Simpson's good, triplet 610. As far as digital meters, I like Beckman's. Tektronix has a series of handheld digital meters that are nice. I like Fluke's a lot. Fluke makes very nice bench meters, and they've been doing that for so long that there are a lot of used, very nice Fluke meters out on the used market cheap. One of them is the 8050A, 8050 alpha. That one has relative measurements, will do decibel conversions and all sorts of stuff like that. Let's see. Frank, you and I talked about this a lot. Am I missing anything on meters?
I don't think so, Tom. I think you did a great illustration of the same signal across different measurement tools, and I think that's great. So I think you've given a pretty good coverage of that.
Okay. Uses for meters in a ham shack. It's your first grab when you have a piece of equipment fail. As a matter of fact, the scope that I was going to use for this talk tonight has shown up with a failure. It's one of these cases where it sat on the shelf for 5 years without being used, and it's probably had a capacitor dry out and power supply. So when I pull it out of the case, first thing I'll do is I'll take this Simpson right here and check all the power supplies. Let's see, in tinkering with designs, a meter can be for checking your power supplies. If you have bought a new power supply and are going to hook it up to sensitive equipment, it's a good idea to put a meter on the output, whether it's 12 volt or 5 volt or whatever, just to be sure that you're not going to toast whatever you're going to hook it up to. Also, if you think you're having a marginal brownout or anything going on with your AC power, you can use either the digital or the analog to check that. Let's see. All right.
Tom, let me ask a
Yes,
question.
sir.
It'll be helpful.
Let me throw this in before you say that. Anybody that's got any question at any time, just speak up. Now, go ahead, Frank.
Listen, one thing that a lot of hams deal with is the notion of, okay, these big old heavy linear power supplies that they used to make are great, but you know, they're a little more expensive. And I say they were heavy. I've got this relatively inexpensive switching power supply, but I hear everybody say it creates noise. Now, talk about that relative to what you just said about, okay, how would you figure out whether you've got noise coming out of a switching power supply?
Ah, okay. And actually, it really depends on the power supply. The switching power supplies are inherently terribly noisy, and the case in point is the early personal computer power supplies. They were terribly noisy. They've gotten so much better. I'll give you an example of some that are not. I have had a couple of switchers from Astron that I have absolutely detected no noise from. Whatever mitigation they're doing is successful. I'm just thinking, I have not run into a very noisy one recently. It's been some years ago. Older ones probably would have more trouble. I know the switching power supplies that you see in a lot of test equipment these days are quite quiet. I think what's happened is that the basic cause of the noise is still there, but the manufacturers have dealt with the noise problem for long enough that I think they have found out how to suppress it. And if you look at the design of current switching power supplies, you see suppression artifacts there. Looking at the output of a power supply on a scope, I have not done recently. You very well might be able to see some noise on the switcher that you wouldn't on the linear. But you've given me an interesting thing to go look at on a high sensitivity scope, Mike. I wonder. Be an interesting thing to look at, and I'll report. I've got a 20 amp Astron switcher in the shack, and I've got several linear Astrons, so I'll do a comparison. By the way, I was planning on doing this presentation from the ham shack, but I am so far as of yet unsuccessful at getting wideband internet up there. Hopefully before we do it again, I'll be able to do it from there. But does that answer your question? Good deal, good deal. Does anybody else have a question? Okay, I'm not hearing anything. Okay, back to scopes. As we just saw in the example, if you've got a situation where a meter's not giving you results and you're not getting usable data, then the next thing to grab is an oscilloscope. And I'll tell you this, I tend to grab the oscilloscope first. It's kind of like the old phrase, cut to the chase. If I'm suspicious that I'm going to wind up using a scope, I've got one at the bench, I've got portables, I'll go ahead and get it out, and then I don't have question what I'm looking at. The only place that's a little more trouble is if you need a current measurement, but there are current probes available and that sort of thing. This scope right here is a good example of a ham-fest bargain. About 6 or 7 years ago at the Jackson Ham Fest, I saw this one under a fellow's table, had a cover on it, and he had $20 marked on it. I figured, it's a Tektronix 422. I remember when those things were $600 or $800 on the used market. And so I asked him what the story was, and he said, well, it doesn't work. Well, I've worked on those before, and they're very well built, not hard to fix. So I gave him his $20. Wound up putting an ECG 123A transistor in it, which cost me about $1.50, and she's worked like a champ ever since. So you can find nice scopes at the Ham Fest. Just do a little shopping. Now, as far as strengths, I'll say this. I don't own a digital scope, but that's what's being made today. I'm not aware of anybody that's still making analog scopes. The digitals they'll do about the same thing. They have features like auto setup. Things are handled through menus and encoders rather than large switches and knobs and things like that. There's no CRT. They write to an LCD panel. Bandwidth is usually similar. This is an old scope. It was probably from 1967 to 70. And 15 megahertz vertical bandwidth was plenty usable and reasonable at the time. And I still use it for portable stuff. But these days it seems like 100 megacycle vertical bandpass dual trace has become pretty standard. That's what you'll see in the beginning level digitals, and that's what you see. There are a lot of those around in analog. The old Tektronix 465 is a good example. The primary differences, once again, with a digital scope, you have the same kind of measurement accuracy that you have with a digital multimeter. The digital scope it doesn't have as many opportunities to drift out of cal. A very well-built analog scope really will stay stable as well. But the digital scope, if you're reading a waveform, you put the cursor at the top, and the cursor tells you it's at 123.78 volts or whatever, then you can pretty well take that to bank that that's accurate. On your analog scope, if you put the same waveform on there, then by reading it off the screen, using the calibrations on the screen, you'll be able to see, well, okay, that looks like about 120, 122, 125 volts. You'll get to the point where you can interpolate that visually once you're familiar with your instrument, but you're not going to get two or three places after the decimal. Now, there's a caveat with digital scopes. It's called aliasing. And aliasing basically is this. Analog scope, when you connect to this connector, you hit an attenuator, you hit a vertical amplifier and a delay line, then you go up here and you hit vertical deflection plates in the CRT. That signal is never anything but analog, and what you're seeing on the screen is a good replica of exactly what was fed in the input connector. As long as you stay within your bandwidth, it will be accurate. You can easily see when you're going above your bandwidth, because as the frequency goes up, sharp edges will begin to round off, amplitude will begin to drop, and that sort of thing. If you're way above your bandwidth, then you will see little or no signal. So there's not an opportunity for misinterpretation. With a digital scope, what's happening is the signal is coming in, going to some amount of attenuation for calibration, and then it hits an A to D converter. It's converted to digital data. It remains data all the way to the point where it goes to the screen. And what the scope is doing is the processor is assessing what it sees. Then it's drawing you a picture of what it thinks it sees. That's fine as long as you're within the bandwidth of that scope. But if you fed it something right at its bandwidth or above it, what happens is it doesn't know that it's missing features of the wave. So it might show you a viable looking waveform that bears no resemblance to what's really there. It's just something that you have to watch for. Let's see, I don't want to miss anything. Another difference, and this may be more significant to me because I've worked with analog scopes for so long. But you notice, let me speed this up a little bit and I'll show you an example. Okay, Now, when you look at that trace, you see, can you zoom in on it? Thank you. When you look at that trace, you see a really fine, well-focused, sharp line. And if you're close enough to it, if there's a tiny anomaly, if you're watching close, if there's a tiny anomaly, you see it. And because there's no pixelization or digital artifacts to mask that, you know, if you see this tiny anomaly, well, it's there. And if I'm not seeing it well enough on this instrument, maybe I need to do something else and try to get a better view because it could be significant. With the digital scopes that I have seen, and you can go spend $100,000 with a Rode and Schwartz and minimize this, but with the ones that I've seen and worked with, the display is made of pixels. And if you've got a horizontal line with no signal on it, you're going to see the odd pixel above and below and above and below, so that a tiny anomaly could be there and you wouldn't know if it was from pixelization or if it was a genuine anomaly. So there's a difference. And it's like the meters, there's trade-off. It's not that one's intrinsically better than the other. They're both good tools. Actually, for some of my lab scopes upstairs, I have a plug-in unit that basically converts that mainframe into a digital oscilloscope with all the measurement, storage, and all that sort of stuff that you expect. I don't use it a lot, but when I need it, it's quite handy. Disadvantages of analog scopes, not as great at accuracy. They are normally larger. A digital Tektronix these days with 100 meg bandpass would probably be about 1/3 of the size of this oscilloscope, and gosh, weight very minimal. This one weighs about 23 pounds. It was thought of in 1967 as being very portable. Let's see. As we said, on the digital scopes, you have auto setup available. Accuracy is extremely good, and you have cursors. You can actually scroll back and forth, put cursors on the screen to measure time, measure amplitude. Some of them offer differential measurements. It's a nice feature. As far as scopes using the ham shack, obviously repair of equipment, monitoring transmissions. Hear that little picture there? Mm-hmm. Monitoring transmissions. Man, is this lit well enough for you to zoom in and show it?
Yes, it is.
Okay. I happen to have this photo. This was many years ago. I was running a Drake TR4, driving an old Swan 1200X amp. It did not have good ALC at the time, and so I set this up. I really wanted to know what kind of power it was making and whether it was properly tuned. This display was on a Tektronix 549 storage scope. The picture was shot with an old C12 camera. And okay, this was from 1993, I believe. And it was feeding a dummy load. Now, that gets into power measurement. I wanted to mention that having to do with the scope. If you don't have, the bottom is just a continuous key down situation. The top was an AM signal with 100% modulation. And you can see that it wasn't 100%. It was probably 50% modulation. But you can read the peak voltage off of the display, figure the peak voltage and the precision dummy load being 50 ohms, and you get an extremely accurate power measurement that way. It's a nice way to measure power with a $100 oscilloscope and a dummy load that will get you basically as accurate as obscenely expensive HP power sensors. Handy thing, handy thing. Let's see, I was looking at the date on that. Yeah, that's what that was. It was, that's right, it's just the tuner. But anyway, that's for measuring RF power and adjusting your loading. Because if you set that display up and you see a bunch of flat topping, you know you're misloaded or mistuned. I know Kenwood, Heathkit, and I'm trying to think who else, several manufacturers either used to make or still make station monitors that are basically specialized oscilloscopes with appropriate connectors on the back to leave in line and pick a signal off so that you can continually monitor your output. It's also handy for adjusting a bug. If you like to use a bug for CW like I do, if you feed your signal to a dummy load, take the signal off and go to a scope, you can easily see what the balance between your bits and spaces is, and bit length and all that sort of stuff. Anybody got any kind of question? Frank, say something. I want to be sure I've still got audio.
Yeah, you got audio.
Okay,
Yeah.
I just want to be sure I could hear.
You bet.
All right. Am I glossing over anything or missing anything? Let's see. All right, I think, let's see, that's pretty well the oscilloscope.
Tom, let me, at that point, I want to interject.
Yeah.
All right. If you can see this book, and when Tom agreed to do this, I bought 10 copies of this from ARRL. It's a nice little book about an oscilloscope for your ham shack, and it's got some of the nuts and bolts details that would be useful as a follow-up to Tom's presentation.
That'd be a great book.
There are 12 people on here, and if you take Tom and me out of it, that leaves 10. I've got 10 copies. If you'll send me an email with your postal address on it, I'll drop one of these into the mail to you. Obviously, I had planned on us being an in-person meeting, and we would kind of give them away somehow. So if you'll send me, Frank, K4FMH, I'm good on QRZ. My email is k4fmh@arrl.net. Again, K4FMH, good on QRZ. And as long as supplies last while operators are standing by, you'll send me the email, send you a free book on oscilloscopes. Okay, back to you.
Hey, Frank, listen, when you send those books out, put my email address in there, and anybody that gets into the book and has a question, just email me. I'll be glad to help.
I will do that, Tom, and that's a great offer to everybody.
My pleasure. I'm definitely one who believes that the scope's one of the finest inventions of modern man. Now, I'm going to talk about network analyzers and antenna analyzers. I'll just show you this little guy here. Let me set a display up here. Let's see. Sorry for being slow. I'm still getting comfortable with this little guy. There we go. Can you zoom in and get that display? Do I need to move it
Sorry,
around?
hold on, I'm sorry, I'm making him drunk. Here you go. Ooh, yeah.
Okay, this is a Nano Vna. It's one of the $50 or $60 ones that Amazon sells. Now, you can show the whole device. You have 2 ports on the end. You have some status LEDs and switches. This is a 3D printed case that I got on the internet. It has a little storage compartment for your calibration loads, things like that. I don't know how to express what a bargain this is. $50, $60 for a bona fide two-port network analyzer. It was not that long ago that to do what this device does, you would have spent $120,000 or $130,000 on an HP device that weighed about as much as a piano, I think. And it's just stunning. It's the idea of having something like this that literally I can put in my shirt pocket. You talk about taking something up the tower with you. I carry mine to the backyard to check antennas. The breakthrough with this one, and I'm a big fan of the Mini Vna Pro. It is about the same size. It strictly feeds its data to a computer. I'm going to show you some plots in a minute. similar capability, but it does not have a built-in display.
I tilt it forward. You've got a glare. There you go.
There
That's
you go.
perfect.
It does not have a built-in display, so you can't walk outside with it in your pocket and make readings on the fly. The fact that this one does is just nothing short of amazing. Now I'm going to get some plots that I've got off of a mini Vna to show you some of what this little guy will do. And what I do for connecting to my wire antennas, let me put my adapter together here, is I've just made I've got a little Pomona pigtail, goes to alligator clips, used a BNC to a male SMA screws on here. So when I have wire antennas, and when I go outside now, all I do is clip to the antenna in the ground, basically across where the tuner goes, and I'm in business. It covers from like 10K to 900 megacycles. You can sweep as much or as little of that as you want to. So, I mean, it's just loafing at HF, which is where I use it mostly. But gosh, the utility and the information you gain is spectacular. And at 50 to 60 bucks, there's not a lot of reason for you to wonder what your antenna's doing and not be able to tell. Now, this is a good example of typical hardware. And I want to show you, there is a program called, Frank, it's Saber, right?
Yes, Nano Saver.
Yeah.
And it's free. It's a community type thing.
Right. And I have it. I have not run it a lot yet because most of the stuff that I did where I needed data on a computer was some time back. And I used a mini Vna Pro and a notebook computer and a printer. All right. This one right here shows, and this is not too unlike what you'd get from Sabre. It shows a Smith chart with a sweep. It shows some marker values. I don't think I have markers on this one. Let's see. I'm not sure where the marker data is coming from. But anyway, I wanted a Smith chart to see where the impedance of this 2-meter antenna was over a certain range. This was done when I was developing a prototype for a company I used to work for. That's the Smith chart display. That's the same thing you saw on the live updated on the Nano Vna. Sabre will print that for you. Let's see, I'm gonna get where, can you see that?
Yes.
Okay. This chart, and once again, it's a similar thing to what you would get printing from Sabre from the Nano Vna. This came from a mini Vna Pro. This is standing wave ratio on this scale, and that's the red trace. And over here, this is the X and R scale. The R is the black trace. The X is the green trace. So you can see as the SWR hits a minimum. Let's see. Okay, I haven't looked at this display in a while. Anyway, it's below 2 to 1. When it hits its minimum, you can see that the R is still a little bit high. The X is not quite 0, but close to the 0 crossing of the X value is where you got your minimum. Extremely useful because it shows it to me all the way from 142 to 150 megacycles. That was when we were developing 2-meter antennas. This was another experimental model, similar display. This one, we had made some mods in order to get a better match at the center frequency without as much bandwidth. Q was too high. You can see the SWR crosses 2.0 at about 152, crosses 2.0 again up here.
Tom, pick it up a little bit. There you go.
Sorry.
That's okay.
Crosses 2.0 up again around 180 or so, and hits a very good minimum. Looks like about 1.04 or 1.03 to 1 at where I had my marker, 170, about 171. So think about how much that display tells you. You can stick an SWR meter in line and see the same sort of thing, but you don't get near as much information. And this all came from one sweep of the device. Here's another one, and this actually is this is an antenna that was very close to what wound up ready for production. As you can see, we're looking from 140 to 152 megacycles. We've got plenty of bandwidth. The SWR, which is once again the red trace, is right above 1.5 to 1. Down at 140 is exactly 1.5 to 1 at 152. So that, but once again, look at all the information you get in one display. This is from a 2-port network analyzer. There are a lot of versions out there. The Nano Vna, in my estimation, and Mini Vna are the two most useful that I have seen so far. This one because it's extremely inexpensive and has a built-in display. The Mini Vna is attractive because it carries a battery that's rechargeable. It covers from 100K to about, I want to say, 200 megacycles. Then there is an extender that you can find on the used market that takes it from 200 up to 1500. That device is about $450. The extender is about $3 something. There are newer models. There's a Vna Pro 2, which I've seen but have not used. And it connects to your computer via Bluetooth. So you can have your computer on the ground recording data, take that up the tower, hook it up, get what you need. Extremely useful devices. There are a good number of antenna analyzers out there that do similar things with just one port, but you don't have the ability with them to do transmission tests. By transmission, that basically is coming out one port, going through a device, whether it's a filter, a radio, a duplexer, whatever you want to see the bandwidth of and the tuning of, and back into the other side. You would actually get a display, a rectilinear display, something like this, where you've got loss, shunt, or transmission, depending on how you look at it. But for checking filters, for designing anything that's a band pass or a high pass or low pass circuit, for tuning duplexers, that's extremely useful. And the single port antenna analyzer does not give you that. Let's see if I've got anything else.
Tom, while you're looking at that, let me just add, for those who are out there who want to own a repeater, buying the repeater is the cheapest part. Buying the duplexers, getting access to a tower, the hardline coax, and the antenna really add up. But what Tom was saying is that with a duplexer, you typically have a device that will block one range of signals while allowing only another. And that's why the 2-port device allows you to measure both simultaneously, because if you do them separately, you can't get them in sync. Is that a fair rendition, Tom?
That is exactly right. And the thing is, you've got to have it right.
And we've talked on enough repeaters that got it almost right, but not quite spot on.
We sure have.
But back to net control.
Well, and the network analyzer, the 2-port analyzer, is so useful. You could use it to align a receiver. You could use it to align a transmitter, duplexers. If you were building a PL-tone circuit or something, just anything that you'd like to measure band pass or high pass or low pass, extremely useful. And there's one other thing I'll mention. Some of these calculations will overload your calculator in your phone. Fellow ought to have a slide rule. I was running some reactive calculations outside the other day, and sure enough, the old telephone calculator, threw his hands up and said, that's too big. So you just grab the old slide rule and you're good to go.
Is that a Pickett?
It's a K&E.
KD, okay. I used to have a Pickett. I used to have a Pickett. Yeah.
So,
All right, does anybody have any questions?
are we going to have an example of how to use a slide ruler?
I'm sorry, say again?
Are we going to have an example of how to use a slide ruler? Because I've got like 3 of them.
Hey, I'll show you. I'll show you. Just the quick thing is, I don't know if you can see these markings or
Hold it
not.
up high. Hold it up high.
Those are the C and D scales. Do I need to move in?
No, you need to back up.
Okay.
Okay, there you go.
Those are the C and D scales. Those are the first ones that you
I'm
learn
so
about.
sorry, y'all. Okay.
Can you focus okay?
Mm-mm.
Would not focus on it?
Mm-mm.
Well, I'll tell you what. I'll just show in general.
Wait.
Maybe it'll focus on my hand.
This one, yeah.
All right. The ones on both ends of the C and D scales are indexes. And if I wanted to multiply, 2 times 3, first thing I'll do is I would take the index on the C scale, move it down and put it over the 2, which is right there on the D scale. Once I've indexed my first number in the problem, the 2, then if I move the cursor down and find the 2 on the C scale, beneath it is 2 times 2, which is 4. All right. 2 times 2.5 is 5. 2 times 3 is 6. If I wanted to take 5 and divide 5 by 4, I would set the 4 up above the 5, and well, actually, no. There we go. The 5 divided by the 4, you'd go down to where the index is, and that's 1.25. Now, the reason I know that's 1.25 and not 125 or 1250 is you carry the exponents in your head. Basically, I'm dividing a 0 exponent by another 0 exponent.
Pick it up high.
I'm sorry.
Pick it up high.
And when I divide like that, it's going to stay the same. The exponent stays the same. That's a 0 exponent. That's a 0. So this is a 0, which would be 1.25. If I was dividing 500 by 400, same sort of thing. I've got a 2 exponent. I'm taking away a 2 exponent, so it would go to 0, which is 1.25. Since you're carrying the exponents in your head, there is no overflow.
I think it depends on how good you are at math, but I'm usually pretty good at that. There might be an overflow in a different area of the head. So.
Let me tell you, I was baptized long ago with slide rules back in the 60s when I was doing antenna calculations. I used to buy those little $1.98 Radio Shack slide rules and wear them until the markings came off of it and go buy another. But anyways, other questions?
Hey, Tom, the
Yes.
Mini and the Nano, I caught those names, but did you say BNA as in Bravo November Alpha, or is it B and A? I was looking for that device.
Oh, okay. The Mini VNA is Mini Mary India, Nancy India, and it is made by, if you look on the web, let me think, look at www. Gosh, I think it's Mini Radio Solutions or something like that. It's a website, I want to say in Germany maybe. That's where I think they're made. It's where a lot of the designers are. And miniradiosolutions.com, I think that's it. And then the Nano VNA.
Popped right up.
Oh, good.
Miniradiosolutions.com.
That's it. That's it.
Thank you, sir.
And Gigaparts over in Alabama is a dealer, and there are some other dealers. I got my mini units from Gigaparts. I think they're in Huntsville, but they've got other stores as well. And the Nano Vna, good night. I don't know who else is making those in China. I think it's multiple people. And Amazon's got pages and pages of varieties, and I think other people are selling as well.
Tom, let me tell you, a reliable dealer with the best price I've found is R&L Electronics.
They're great.
Roger and Lema Electronics up near Cincinnati. Roger, who is the R, took over the business from his father. They were the first MFJ reseller. Just a little
I did
trivia.
not know that.
But R&L Electronics, I would advise you to check them. They have the best price. They get it out quick. Now, Gigaparts also sells them, and if you're Gigaparts customer, as I am, they're also very good. But very often, Gigaparts will be out, and Roger will have them at R&L. So just FYI.
They're a fine dealer too, Frank. I'm glad to know that.
I sent the mini radio solutions out to everybody on chat, Tom, so they've got a link up in front of them.
Good deal. And their current version, they have two on the line right now. One is the Mini Vna Pro. It is the one that has the battery, the built-in Bluetooth, and it's basically an update of the one I have. They also sell one called I think it's called the Tiny Vna or the Vna Tiny or something like that. I don't think it has a battery, and I don't think it has Bluetooth, but I want to say it's got a much wider frequency range. They don't sell the extenders anymore, but they've improved the frequency coverage of the devices themselves. And the quality of construction on those has been very good that I've seen so far.
One thing I'll add is there are a couple of varieties of the Nano VNA. There's a proliferation. In fact, Tom, I think the one that you got's a 2.8-inch screen, something like that.
Yeah, that's right.
There's a 4-inch screen out.
Yeah.
Which is, you think, well, that's not much bigger, but if you multiply the X and Y, the width and the height, it's more.
Mm-hmm.
I have one of those as well, and you can really tell the difference. Of course, you can hook, as Tom said, you can hook both of them up to your PC and have as big a display as you want. But bear in mind with that, and I order from China a lot. Sometimes I jokingly say that my second most used tool on my workbench is my carpet knife, because I use that to open all the packages from eBay and Amazon. But keep in mind, particularly with COVID, a lot of shipments in China are sequestered in Singapore for 2 weeks. So some of these U.S. dealers, if they have what you want, you might think about that.
Well, that's true. And I'll tell you something else, Frank. If you're a tinkerer, the Nano VNA is for you, because have you seen all the firmware variants? I mean, everybody and his brother is tinkering with the firmware and posting it on the internet. I'm fixing to update mine as soon as I feel good about the process. The only tick I found that I don't like is when you see a complex impedance read out, it reads it as a resistance and an inductance or capacitance. Well, everybody that does much impedance measurement wants resistance and an imaginary reactance, or the imaginary part as an ohms of reactance. And
so sometimes those are called J-ohms, and if you look at an MFJ analyzer, it will have that as J-ohms. And the Nano Savers, I think I shared with Tom about a week ago, it will give you the display Tom's talking about. That's one advantage of the Nano Saver software.
And let me tell you, I found a couple of firmware updates out there that will do it on screen. I just haven't worked up the nerve to update mine yet. It's an interesting process, and I'm a little scared of turning it into a rock.
Well, Tom, one of our board members and who's on here, Jim K0UPW, bought one, and he thinks he bricked it.
Yeah.
So those have gone before you. I'm not convinced it's, as they say in the legislature, dead when the legislature's over. It may be dead, but we got 2 more deads to revive it. And so I'm going to get that from Jim. And Tom, maybe you and I can get together and get his work, and that'll give you some courage to go back and redo yours.
There you go. Well, and the good news is if you break it, you can buy another one for 50 bucks.
Well, but as I was telling Jim, that thing starts with nothing. I mean, absolutely nothing in memory. So there's nothing to corrupt in the memory.
No.
It bootstraps, and it's getting the bootstrap to work correctly that sometimes there's an error, like there is when you update Windows. I mean, it just happens. So, you know, it's a minor investment, but it's very, very revivable in 9 times out of 10.
Oh, yeah.
I certainly hope so, because mine, when you turn it on, it comes up with the original screen that says Nano VNA and all the other things, you know, modes and everything, and that's as far as it goes.
Uh-huh.
You know,
Yeah, that's what I'm.
That goes away. It goes to your first display screen, and you can call it the menu, and you can't do anything with the menu though. That's as far as it goes.
Yeah, yeah, and you know that's the whole thing. You got a certain amount of risk.
Yeah.
That's
Well, they offered me a 35% rebate and told me to get somebody to repair it locally.
Oh, I hear you. I hear you. Well, Frank and I are gonna get together and see if we can get that one going, and hey, we're gonna figure it out.
Now that's good because I use a mag loop antenna. I live in an apartment complex, and the only antenna I have is a mag loop, and I've got to be able to tune that thing before I, you know, hit it with power. So that type of thing.
Listen, I'm with you. I'm with you. Well, I think it'll be an interesting project.
Yep. Well, if it works, it works. If it doesn't, nothing lost.
Yeah, that's true. And that's the danger. I mean, you got all kind of folks out here working with a firmware, no telling what fabulous features you're going to come up with, but there's a risk to it, you know? Anybody else have a question? Frank, have I missed anything?
Tom, I don't think so. I think you've given as I knew you would, a marvelous overview. You've touched on some personal experiences. You've touched on some variety of good, bad, and a little bit ugly on occasion or two with a particular piece of gear. I think you've warmed a lot of people up here to what they might want to get. And as we all know, sometimes you can find a real bargain. And the Nano VNA, it plays well over its fighting weight. And so if you do have a problem with one relative to what you would pay, you know, for a professional version, if you will, it's still a great game. So it's really worth getting for the price point. I'll add this, and I said this before we went on air. Tom, I sent you a thing. There's the same people that did the Nano VNA have come up with a small spectrum analyzer called the Tiny SA. Well, there was a guy whom I know bought one and said, I don't know why I bought it as an impulse purchase. I could have bought a hamburger at McDonald's, you know, the same. So I bought it off of him tonight, and he's going to ship it. So, Tom, I'll share that with you. And that's a little device that also will have some utility, and maybe a future program we'll talk some about that. Tom, I think you've covered it. I want to ask everybody to let's give Tom a little round of applause and unmute your mic if you would. So,
Absolutely, appreciate it.
Y'all are mighty kind. I have really enjoyed being here. I'm just sorry we couldn't do it in person.
There'll be enough.
I've carried a digital Tektronix for 15 years and never knew what Aliasing was, but I'd read about it. So I'd like to thank you. I like that program. Thank you.
Oh, this is great. Well, I enjoyed it. And seriously, when Frank sends those books out, if anybody's got a question or if I can help, just email me. I'll be glad to.
All right, I've had about 3 people send notes in. If you want one, go ahead and do it because you'll forget it and then they'll be gone. But I'll get them into the mail by next week at the latest, and hopefully you'll use them. I've had a Kindle version of it. I've learned stuff, and as I said, Tom is my Elmer on test equipment, and I continue to learn from him. And Becky, I'll have some roasted pecans there for your work tonight, tomorrow.
Thank you, dear Frank.
Only problem with them, Frank, is they don't last very long.
Yeah, but I found a good source. Sam's has them in the 2-pound bags for less than what Kroger sells the 1-pound bag for. So there you go.
Excellent. Thank y'all for letting me be here. I enjoyed it.
Thank you, Tom. Appreciate you.
Yes, sir.
Yeah, thank you, sir. Appreciate it.
Quentin, you got anything for the group here as president?
No, sir. I apologize for my absence. I'm glad to be back in Mississippi this week because
Good.
it's been some hard work, but I got two good guys taking over for me in Texas, so I hope to be around a little more often. But
Tell everybody what you've been doing. I'm not sure everybody knows.
well, I service medical X-ray equipment. One of our new lines is Samsung, and Samsung just got DoD contracts. So I have been for the last 5 or 6, 7 weeks. I've been to Fort Hood and Killeen, Lackland Air Force Base, Laughlin Air Force Base, Fort Hood, William Beaumont Medical Center. I've been on military bases stretching from Fort Hood and Killeen all the way down to McAllen Medical Center down at the very tip of Texas, and from El Paso and New Mexico right there all the way back to Beaumont, which is about as close as you can get to Mississippi and still be in Texas. And I've been traveling over there all week long and coming home on the weekend, spend the night, and head back out. So I'm
Well,
glad
they just let you drive on up into a military base with all that equipment, don't they?
I've had to sit through some lines quite often as dogs sniff my truck. And once or twice, I actually had my firearm with me, and I was kind of sweating, thinking if they found it, I was going to probably be thrown in a brig somewhere. But after they got used to me, they kind of waved me on through. So it was a lot of equipment. A lot of times they would look at it, see that big mess, and go, yeah, go on through.
Well, very good. I just let folks know what you do. And with everything that's going on, the equipment is such a critical need. So it's good, Quentin, that you're there doing that. So that's all I've got for our program. Tom's done a great job as I knew he would. And next month, we've got John Strumpf going to talk about preparing for contest operation. And John is like us. He doesn't have a super station, but he does have a station, wire antennas, last time I checked. And he's very passionate about getting into contesting. So I thought he'd be an excellent speaker to talk about, it's great to have, K3LR up that runs DX Engineering. It's got a multi-million-dollar station. Well, that's wonderful to hear about that. Unless I've misjudged some of you, I don't think any of us are going to be doing that anytime soon. So one of the things about John Strumpf's presentation is he's a blue-collar ham, for lack of a better way of putting it. He's building his station kind of like we have. So I thought he would be a good speaker to tell us how he prepares, for contests. So that's coming up next month. In October, we've got Shack Night. I think JD had asked people to send him pictures of Shack, so he's kind of putting that together. We'll also have elections. And then in November, we'll have the bookend from starting off with the most famous ham in Mississippi, George Thomas, for our first meeting. Our final program meeting will be Rob Sherwood, and the guy who's the guru for measuring rigs and that kind of thing. And his talk will be, how do you use my tables? He has the famous Sherwood table. So we'll round out this year with a challenge of having to do it remotely and that sort of thing. And thanks to JD and his Zoom account and his capabilities, we've managed to keep on keeping on. And so just want to thank everybody. And that's all for me. But I'll let JD sign us off.
Frank, one thing just to mention, the VE test session. It's if anybody wants information about it, it's on the website and on the Facebook page. That's coming up on the 15th.
Right now, is Brian, our VE liaison, is he there? He's muted, I think, isn't he?
Is he there?
He's like those online tests. People are supposed to be in school online. His computer's on, but nobody's home. Anyway, just pulling Brian's leg. Now, Brian's doing a great job keeping the VE test. He's using his church site to do that. And Jim Martin's done a great job in getting that information out. So if you're interested in testing, but guess what? Irby doesn't need to test anymore. You know why?
He got it.
He got his extra. So now he's got to get VE status, Irby. That's just a hint. So you can help out with doing the test. So JD, I'll go back to you and I'll mute myself and you can sign us off.
All right. Well, thank you very much. Y'all have a very good night. Look for this video in about 2 days maximum. It'll be up on our website, and I'll have all the relevant links to the Nano VNA and all of that up with that post. So other than that, y'all have a very good night. Thank you very much.
Thank
Thank
you,
you.
Danny.
Good
Thanks,
night.
everybody.